It is so wonderful to see such a global community. We have folks from Massachusetts, from Serbia, the UK, Brazil. It's so wonderful to see this amazing global community. All right. We have 165 participants. I think, wow, look at that. We have folks from Turkey, Argentina, India, Germany, Boston, Massachusetts. It's so wonderful to see you all. I think we can go ahead and get started since we have a good amount of folks here in the webinar. It is so wonderful to see you all. Welcome to the new members of our community. If you haven't met me yet, my name is Amy and I'm the University Innovation Specialist, one of the University Innovation Specialists here at the Good Food Institute. And what that means is that I work with students and scientists and researchers at universities to advance alternative protein research and innovation. So if you have any questions about navigating GFI's resources, you can reach out to me at amyh@gfi.org. So since our last seminar, since this community expanded to include scientists in addition to entrepreneurs in the last month, we've had over 500 scientists join from industry, academia, government, and beyond, who are all really passionate about applying their skills and expertise to the alternative protein space. And we're so excited to have you here. Our members now span over 36 countries across all 6 continents that matter. And I think it's grown so fast that we have experienced some growing pains. So we apologize to anyone who's had even a mildly frustrating experience. We are actively working on building a better user experience for our community members, and we're very thankful for your patience in this time. So our agenda for today, we'll start off, I will introduce our speaker, Dr. Ricardo San Martin, who directs the AltMeat Lab at UC Berkeley, and he'll talk for around 35 to 40 minutes. Following that, we will have a Q&A for roughly 20 minutes, and then afterwards, that will take us to the top of the hour. We'll have an optional discussion portion for 30 additional minutes for those who want to stay on and have a broader discussion about things in anything related to alternative protein. So this is a bit of a new format. I just want to get everyone acquainted with this new webinar environment. At the very bottom, you can see that there's a chat portion where you can say hi to everyone as you've already been doing, or otherwise express excitement. There's a Q&A portion at the bottom of your screen that you can use to ask Ricardo questions during the course of his seminar, and we will get to them at the end of his presentation. And if at any point you do want to be more active in the conversation and come off mute, you can raise your hand. All right, so without further ado, Ricardo, I'm going to hand it over to you. Thank you so much for being here with us today. Many of you know that in addition to being a brilliant researcher, Ricardo also leads the AltMeat program at UC Berkeley, which is a really incredible experimental design or experimental educational and research program that has already yielded a few startups in the alternative protein space. So we've just been floored by his successes in the last few years, and we're so excited to learn from him today. So Ricardo, I will turn it over to you now.
Oh, thank you. Thank you, Amy. Can you hear me well?
Yeah, I can hear you well.
Okay, great. Hello, everyone. Well, I thank GFI for organizing this, and I'm really here to learn because our research, it's just starting, and I know in the audience there are many people that probably will come up with brilliant ideas to help us navigate what we're doing. So with that, let me let me get going. And so the title is using nano-emulsions to improve fat encapsulation, but really what we're doing is adding oil to plant-based meats. And this is a GFI funded project, and we have we're lucky that we have as an advisor Professor Clayton Radke, which is very good in surface chemistry and colloidal chemistry, and students that are with us, not anymore, not the last 6 weeks, unfortunately, they're all gone. Okay, and so let me show you what I plan doing. And so the topics for today will be, I'll talk a little bit about my background, how I got involved with all this, a little bit about the ALTMEET program, and then I'll go into the research, and then some future work that we plan doing related to the research. Okay, let me put the clock here. Okay, so I'm sure I'm not going to exceed any more than 35 minutes. Okay, and so this is about myself. This is when I was very little. Okay, and in Chile, and from there I moved to getting a degree in chemical engineering, then a master's degree from UC Berkeley in chemical engineering, then a Ph.D. in biotechnology from Imperial College. And then I co-founded a company that is about natural plant extracts, and some of the extracts are the ones we are using in this research. And that was done in Chile. And then, let me see here, then I moved to the Bay Area back again. I was visiting a scholar at Stanford for a year. And then I moved to Berkeley, and since 2017, I'm the director of the ALTMEET program, which is a program that is housed at the Center for Entrepreneurship and Technology, and that's housed in the School of Engineering of UC Berkeley. So we are not a science department. The research I'm going to show you is our first research we are doing, because all our classes are really more experiential, but they're not really, I mean, we don't award master's degrees or PhD degrees or anything. We serve about 1,600 students from UC Berkeley, and we give them entrepreneurial skills, okay? So this is my world. It's always been about plants and trees, okay? So here I am in Chile in a plantation of these trees, and here I am working, developing my products in the kitchen. That was 4 years ago. Now I'm back to the kitchen, and I expanded to I have my lab in the garage, really, okay? And what I do is, I created a company that started as doing foaming agents for beverages. Some of them, the root beer in the US has this foaming agent. And I'm gonna talk more extensively of the structure of the foaming agent, because that's what's being used today in the research we're doing, okay? So it foams. But besides foaming, some of the compounds are quite active immunologically, and they're part of the malaria vaccine by GSK. They're part of the shingles vaccine, and maybe the COVID vaccine. This is a company called Novavax that is developing a vaccine based on some of the components that are in the extracts that are used also for food and beverages. But some of them are very purified, and so they are developing. You can see how the stocks have changed in the last weeks for them. And they're very confident they're going to make a new COVID vaccine based on these extracts. Good luck. Hopefully they get there. Okay. Okay. Now, family-wise, I have 4 kids. So I have Lucas that lives in Chile. He eats a lot of meat. Okay. And then I have Pablo, New York, very active vegan. And then I have my daughter Zoe. She's an ex-vegan, but still almost vegan, okay? In the previous presentation, I introduced her vegan, but not anymore, not strict vegan. And then I have little Agatha, that this is an old picture now, she's 9 years old, and some homeschooling, as you can tell. And she's really all about sugar, okay? And let me talk a little bit about the ALTMEET lab at UC Berkeley. So the ALTMEET lab is really meant to empower students. And we are trying to create the next generation of healthy, sustainable, delicious, and affordable plant-based foods. And the reason we put healthy, sustainable, and delicious is we try to instill in the students a critical point of view that some of the products that are out there may not be so healthy and may not be so sustainable, although some of them are really delicious and they may not be affordable. So our students get this entrepreneurial mindset that things can be improved. So this is just a first generation, what is out there. And the picture here depicts two former students of mine that are now in Switzerland, in Lausanne, in the Center for Innovation of Nestle, developing a chicken. Okay, the program, very shortly, it just from 2017, one class with the full support of the Good Food Institute. That's how we started. They gave us contacts, they came and talked to the class. And since then, all what has happened is it has grown. So we have a lot of alumni in industry, we have more startups, we have more funding, we have industry partners, research, we just started, and that's what we're going to talk today. More students and more classes, and that meant funding, right? And funding hopefully came, and besides the GFI grant, we had very generous vegan donors and companies that are giving money to make this program possible, okay? My job is really creating a great learning environment. I'm like the master of ceremonies here. I mean, like the students are the ones that are really in charge, okay? So here we have our first generation, and I can see now many of them in Possible Foods. I mean, like there are many in industry of all the students here, okay? And we defined ourselves as learners. This is a new space, so there's no really major textbooks on this or a lot of professors working on this. So really what I try to create is a hub where we all learn. And the hub consists of industry challenges that are done by, let's start with the courses here. So we are giving like 2 or 3 classes per year, 30 or 40 students per class. We have industry partners. We have access to venture funds and accelerator like MISTA, Skydeck. MISTA is from Givaudan, Skydeck from UC Berkeley, Nestle. And the research is guided by what the industry is facing today. And we have research grants, and that's the GFI grant we have, okay? And our industry partners are Givaudan, that is the major producer of flavors in the world. We have Merck, that it's more interested in lab-grown meat, which we do a little, but we're really focused on plant-based. And Miyoko, which many of you may know, but it's a vegan cheese producer, and Nestle, based in Switzerland, okay? And what kind of projects we do? We try to do all of it, okay? But we're trying to do yogurt, bars, chicken, and we are trying more and more to see what we can do with fermentation. We're trying to structure bottom-up cheese, and we have a lot of faith in beans, trying to stay closer to what nature has given us. So trying to move away from so much of the processing that these foods has. Okay, so with that, 10, 15, okay, great, I'm doing okay with the time. Let's get into the project that the Good Food Institute has generously sponsored. And so you all know that oil is central to a good consumer experience. And here we have, you know, the Whopper and the Impossible Whopper. I think they pull out this one, but at the time, and you can see this is the fat content of the whole burger, not just the patty, but you can see that the content of fat and saturated fat is very similar, and it's high, and so that leads to a good consumer experience, but at the same time, it's not the most healthy thing you can eat, okay? Both the animal-based Whopper or the plant-based, they have high levels of saturated fat, and clearly the Impossible has lower cholesterol, but then comparable sodium. So it's questionable its healthiness, but central to all this is the fat that has to be there, okay? Now the way fat gets in or gets out of the raw materials that are used to develop these products, this is what I'm going to talk now. So here you have soybeans there, and soybeans are originally were meant to produce oil. So the first thing you do is you extract that oil with hexane normally in a chemical plant, okay? And then you take the oil out, and then you go to another chemical process where you precipitate the protein fraction of the that is present in what's left in the cake that's left after the oil has been extracted, and you start isolating this pure compound here, which is called the soy protein isolate. It could be done with other raw materials too, but it's an isolate. So it goes through all this chemical processing first. The traditional ways, people are doing other stuff too, but the traditional ways, it goes through an extruder where these proteins here, which are globular and they don't have much structure, get structure here, they align and they produce this kind of fibrous structure that you can see in the picture here. Okay, that doesn't have much taste. It's not so, depending on the plant, it's not, the taste could be bland, but it doesn't have any taste. So, and it doesn't have any oil. And the reason it doesn't have any oil is because for this extruder to work, to produce the amount of shear to align the proteins to go from here to a fibrous structure, you don't have to have almost any oil here. If not, this extruder doesn't work properly. It slips because of the oil content. So you have to add the oil that you took out here, you have to add it back. And normally it's coconut fat that what is being used, okay? And the reason coconut fat is being used is because it has a high melting point compared to other oils that are liquid at room temperature. Then you bring a chef into the equation. It looks for odor or taste blockers and development of color and all of that. That's the chef's mission. Yesterday in our class, we had one of the original chefs of Beyond Meat, Chef Dave Anderson, that explained us how hard this is to get the right, you know, not only, I mean, the texture is taken care of with extruder, but how hard it is to get the right flavors there, okay? And then finally, you get the patty. So that's the way it's done. Now, our research is concerned with this part here, that we are trying to replace the coconut oil and see if we find a better way to incorporate the oil to this fibrous structure here, okay? So let me just move away from, okay. So here, Amy, if you are listening, tell me if the video plays, please, okay?
Yeah, it's working well.
It's working well? Okay, so let me tell you what you are seeing here. So here, you're seeing a Beyond Burger being cooked, okay? And I'll play it again. And this is in my kitchen. So you will see all the oil leaking out there, right? And some color, right? But the experience cooking this, it's quite, I mean, it's not so, unless you're cooking like in a barbecue where the oil sort of gets out and you don't feel, but when you cook this in the house, it's really, I mean, it smells everywhere. That's my experience. So my wife has, in a way, told me not to cook that much here, okay? So now the idea is like this experience and the leaking is not very good for the consumer. And so the proposed solution is to add the oil as an oil in water nanoemulsion with that size of droplet size, okay? Between 200 and 800 nanometers to improve the diffusion and retention of that oil inside the extruded plant protein matrix. So the idea here is, instead of adding it post-extrusion as a solid fat, we structure the oil in this very small globules, and then that is where we're going to soak the plant protein matrix, okay? And besides doing that, so it's retained more, we plan using more healthier and local oils, such as canola or sunflower or corn or whatever you might come up with, okay? And how do we do that? When we wrote the project, we proposed to use a novel vegan emulsifier, which are the sapones of Guyaca saponaria. And I say novel vegan because until a few years ago, this process wasn't, the extraction process for this sapones was not vegan. It had some compounds in the purification that from animal origin. So that has been solved, okay? And this is how the tree looks like. It's a tree endemic to Chile, and the flower is very beautiful, as you can see here. And it's a tree that grows in the wilderness, and it's been exploited almost over 100 years. And before we started, it was just the bark. Now what we do, we prune the tree and we take it from the limbs. We take the saponins that are needed for the food industry, okay? This is the structure of the compound, and it has a hydrophobic center here, which is has affinity with oils and fats, and it has these chains which are sugars here, which are more hydrophilic. I mean, it has hydrophilic groups. Now, some of the saponins, they have this here, but most of them just have this here. So it looks like a crab, you see, like a pin. You have this two hydrophilic compounds here, and you have the central group here, which is hydrophobic, okay? So that's sort of the general structure of the saponins. And Professor McClements just sent me an email a few minutes ago that he was listening. The talk was prepared yesterday. So Professor McClements is a world expert in emulsions, and he started to do active work with this compound, as well as other teams. And that called my attention because I said, why, with all the surfactants available there, why is it that, you know, people that really know about emulsions are using this or thinking about using this surfactant as a good surfactant for the food industry? And so I easily can count over 50 papers in the last 5 years or more, 100 papers maybe, on the use of saponins as surfactants on this, specifically this saponin from this quilaya tree, okay? And a very good review for those that are interested in that was just published in Germany in 2019, and it talks about all the properties and the functional properties and characteristics of these saponins, okay? Now, our starting point when we started the research, we looked at the research done in China, and they were doing very interesting research because they were able to do nano-emulsions. They were able to put water, they were able to put oil, and they put the saponin, and they emulsify it, and they create a very strong structure. But it was so strong that they could even spray dry it. They could do a powder, really inside each of the little globules, there was oil inside. So they were able to do very, I would say, structure kind of oil. So that caught our attention. We thought about doing this at the beginning, but then we thought, since the soy protein isolate or the pea protein isolate is a powder, we thought it didn't make any sense to make an emulsion, dry it and create a gel, and then rehydrate the whole thing, because you have to rehydrate anyway to get that protein isolate with the right amount of water needed to create a burger, okay? So we started this way. That's a picture of the product. It's distributed by Ingredient in the US, which is a large company, which is part of our community too. And they come to our classes and give talks, okay? And the advantages that we've seen in the literature is like, it produces oil and water emulsion with small droplets sizes. It has a low surfactant to oil ratio, lower than lecithin and other emulsifiers out there. And in one of the papers, it says 1 to 10. I'll show you research where we think we can even lower that. So that means about 14 mix of saponin per gram of oil. And then it has a high stability to pH and heat. Just at pH 2, you will find some problems of aggregation. Heat is very stable. We actually concentrate, all the products are concentrated with high temperature. I mean, like over 100 degrees C, okay? And when it forms highly elastic films around the oil droplets. So it has a strong resistance to shear, and that's what allows them to spray dry them, right? Because when you spray dry, you go through a nozzle, and that's a high shear process. And even with that, it holds, okay? Now, there is a problem. I mean, and as everyone, I mean, it has good things and not so good things. The regulatory issues are something that has guided our research. So if you go and look for how much saponins you can eat, the allowed daily intake, which is published for every compound you're eating in the world, tells that you can eat 3 mg of saponin per kilo of body weight per day. Okay, let me check my stopwatch. Okay, I'm doing okay. And that means a person that normally the average person is around 65, 70 kilos for the World Health Organization. So you multiply this by 70 and you can eat 200 mg of saponin per day. That's what is allowed, okay? And there we are okay with the research I'm going to show you. We are complying with this one. The problem comes that there's an additional restriction, is how much a product can have saponins, and it's around 200 mg per kilo, which means that a 100-gram burger, a patty, can only have 20 mg, okay? That is to comply with the restriction of the concentration. And it means that if a burger has 15 grams of oil, you just need to add 1 or 2 mg of saponin per gram of oil, and you are already there with a 20 or 30 mg of saponin per. The thing is, burgers are a little bit higher. It's 113 grams really, a patty. So you can go up to like 2 mg of saponin per gram of oil, okay? And as I show you here, some of the research prior to ours shows that 14 grams make very beautiful, 14 milligrams, sorry, makes very beautiful emulsions, okay? So this, I thought it was good to show you what we are doing. So we are, experimental design so far has been, we first start with mass balance calculation, meaning like, what does a burger has? So a burger has, these are average contents, about 60% of water, 20% of protein, and 50% of oil. And that other 5% can be binders and salt and other stuff, you know, to make it more colors, to make it more tasty and appealing. Now, if you do the mass balance here, you adapt that you have to prepare a 20% oil and water emulsion, right? And add it like at a ratio of about 2 to 3 parts of this emulsion per part of protein isolate. And so if you soak the protein isolate in this emulsion here, you end up with something like what is up here, okay? So we prepare the emulsion, we're using a sonic raptor. I mean, there are other more efficient ways to do that, but that is what we're using to start with. And we do 2 things. This is what we've done first, is to soak the protein isolate in the oil and water emulsion. We add some binder. This doesn't have any taste. We do the cooking and we measure the oil loss. And I'll show you the results that we have with that. The other idea, since we are encountering regulatory issues, we have to optimize or minimize the saponin to oil ratio in milligrams of saponin per gram of oil. And so we test the stability of the emulsions, and we measure particle size and zeta potential, which are indicators how stable the emulsion is. And we know we have to have like a maximum of about around 2 mg of saponin per gram of oil. That should be our upper limit, okay? Now, this is just a picture in my house, how we're doing it. You take the saponin here, you get the oil, you put it here, you go through the sonic, and you emulsify that. It looks like a milk. Then you soak it with the protein isolate, and then we cook these little patties here, and we measure the oil loss. Okay, and so that's what we are doing now. And what the preliminary results are indicating is that we can incorporate canola oil or any other oil with minimum oil leaking. A normal weight loss of a Beyond Burger is around 22% in the cooking process, okay? Now, it could be higher. This is the cooking process we are doing, like standard for all of them. A canola oil that is not emulsified, let's say I just add the canola oil and prepare the burger, the patty with that, it's very comparable. It's about 18%, okay? But if I add the canola oil as an emulsion, it's only 10%. So here you can see in this video again how they're cooking. We have the Beyond Burgers, the reddish ones, and this and the other patties that we have prepared. They have similar amount of oil, and you can see that they don't leak. Okay, and now moving. That's again. Let me see. Okay, some of the data we have very nice particle size distribution, you know, and a very sharp setup potential. So here it was done with a lower, just 10% oil in water emulsion, but our results with 20% oil in water are very similar to this. And what we have done is trying to minimize the amount of oil of saponin covering those little oil droplets and see what happens. Because we don't have to have like a super stable emulsion in time. We just want to do this and then soak the protein isolate. Okay, so this is what we are seeing. We are seeing that as we move from the amount of saponins per gram of oil, we start decreasing. Then what happens is, as expected, the average droplet size increases. The setup potential remains really similar, right? But this is important. Now, if we leave that over a week, they will coalesce, okay? But it will hold for a few days. Now, this is not enough. This is around 5 mg. That's still like twice as much, or a little bit 2.5 times more than what we need to comply with the regulations. And so the next steps, we'll consider use a mixed surfactant system like the saponin and soy lecithin. There's research out there that shows that with the lecithin you can reduce the amount of saponins that you're using. And then we have also seen some research where you add some alcohols, which are used as flavoring agents. And so adding alcohols to surfactants really minimize significantly the amount of saponin. So we're looking into that too. And we just recently acquired a texture analyzer to see if those burger properties change or not with this new method. Fortunately, it's in the lab. Then we are teamed, thanks to the GFI, we are teamed with Nutriati, which make available to us a recipe and send us all the material to prepare burgers so we can use them in panels. Because so far, one of the problems we've encountered is that the companies that do these burgers, they're not sending us any sample of defatted material for us to test. So, but with this Nutriati recipe, we plan to move forward with that because this is a tasty patty, and it doesn't bleed, but it's quite nice. So we are going to do that, but first we have to optimize the amount of saponin we're going to use, and we have to test if the lower oil content gives the same experience, because that could be another approach. Since there's so much oil that leaks during the cooking process, we may find that we don't need to put those 15 grams of oil there, but maybe with 12 or 10, finally what gets into our mouth will have a good experience anyway. That's something we have to test, okay? So with that, I want to thank everyone for listening, and I really want to hear all your comments because, as I said before, I'm here to learn, and really, this is the chemical engineering approach to emulsions. I'm not an emulsion expert, I'm learning, and but it may be one of the solutions that the industry needs. So with that, Amy, should I stop sharing?
Yeah, you're absolutely welcome to stop sharing. Thank you so much.
I did it in 30 minutes.
Yeah, you made
Exactly.
amazing time. Well
Yeah, I
done.
could have talked more about my life, but I didn't. Okay, stop sharing. Okay, there we go. Okay.
All right. So we have a lot of questions that have come
Oh
through
no.
in
Yeah.
the Q&A bar, and I'll read them out loud, and you can answer them as you see fit. To everyone who hasn't yet submitted their questions, you can see the Q&A section in the lower bar of your desktop client, and feel free to submit your questions there. Awesome. So our very first question comes from Thomas Turner. And they ask, nanoemulsions would need to pass, would nanoemulsions need to pass novel food regulations in the EU?
I'm not familiar with the EU regulations, but I don't think so. Perhaps Professor Mike Clements later in our discussion can add to that. But my understanding is no. I mean, it's not a new compound. Oil is oil, water is water, and saponins are approved in the EU. These saponins have an EC number, so an E number, sorry. So they're approved. Actually, the regulations were just reviewed by the European Union, and they even raised the amount of saponins that you can eat compared to the FDA regulations.
Awesome, thank
So
you.
I don't think that if they are delivered as nanoemulsions, it will have any regulatory issues.
Yeah, I think what we've just received a message from Julian McClemens that says, I think they would have to be below 100, so it should be okay.
Okay, okay. Thank you, Julian. Okay.
Awesome. Next question is from Luca. Luca says that you talked about the retention of oil and how oil leaks from Beyond Burgers. Is that not something that is beneficial in terms of being comparable to meat? Meat does, after all, leak oil when you cook it.
I think if you want to, it all depends how you design those burgers, right? If you want to design them with the same health issues that an animal burger has, then you don't need to do what we're doing. You can add the coconut fat and have the saturated thing, but if you're concerned with human health also, and besides animal suffering, then you have to do something about that. And so it's the possibility of lowering the amount of saturated fats and improving the nutritional content of a burger. I think that's our design constraint that we're adding to when we design a burger, right? It has to be good for kids that eat this. It has to be good for people that have obesity problems. I mean, good, so sort of good, okay, but better, so to speak, okay? So that's why, but if you want like the same experience of oil leaking in, you know, a smelly house, it will smell more like coconut than meat, but the problem has been solved.
All right, our next question from Eva Summer. Does the nanoemulsified oil interact with the plant-based proteins, or can it be seen as two different phases?
That's a very good question. We don't know exactly. We know saponins interact with proteins. We don't know what happens at the microstructural level, how they bind there, exactly how they're binding, if they're being retained more because of capillary forces more than chemical forces, but we don't know. We don't know that. Saponins do interact with proteins, but we don't think that's really what's happening here. We think they're more retained because of the microstructure of the isolates. That would be my answer. But bottom line, we don't know. Okay. Yeah.
Thanks. Olivia asks, which parameters are used to search for healthier oils?
Here, since I'm not, we talked to the people from the nutrition department and at Berkeley, and they gave us a list of what they think they're healthier. That doesn't mean that they're the healthier oils. I think the parameters, again, it's a design problem. it could be, I mean, one of the design constraints we have to instill in the students is we have to move to more local raw materials. So this could be a solution. One oil in one place of the world could mean another oil in another place of the world. What we're looking is more the structure of saturated, unsaturated fats. That's one indication. Now that's controversial too. I mean, some people say there's no problem with coconut fat, right? But we're trying to, with the more accepted guidelines around saturated, unsaturated fats, that's where we are. And so we try to be, let's say, local. Let's say you take one of these margarines, you know, but they have palm oil, right? I mean, those vegan palm oil comes, you know, from not exactly from Midwestern US, okay? So it's a design, it's a balance between healthiness, local availability, flavors, and whatever, what is available there, okay?
Thanks, Ricardo.
Yeah.
All right, we have only 34 questions left to go. So brace yourself.
I don't know. I think I'm gonna answer that. No, yeah,
Okay.
no comments, that kind of thing. Yeah.
All right, one question from Alan. Saponins can decrease protein digestibility, and already plant proteins are less digestible than animal proteins. Does the use of saponins decrease even more digestibility? Decrease the digestibility even more?
This very hard question. I mean, I don't know if they decrease. Maybe I'm lacking some understanding there, because I don't know they decrease protein digestibility. I know they decrease cholesterol absorption. I do know, right? And that's proven many times. But in terms of protein digestibility, I know some saponins do. I haven't seen research with Equilea saponins that they are like doing that. Actually, when they're used as a feeding additive to animals, they gain weight faster. So I'm not sure about that, how that works, but doesn't seem to me that it's going to be significant. The amounts we're going to add, that we're adding, they're minute amounts. So I don't see that that's going to play against us.
All right, thanks, Ricardo. From Angela, why is the soy oil, which is taken out of the bean, not put back into the soy texture? Why instead do we add coconut oil or palm?
That's a good one. But I've talked to the companies that they do this, like Beyond Burger, and they just like those white. The coconut has this. I mean, it's solid, right, at room temperature, and it looks like if it was real animal fat. So it's more like an aesthetic thing. It's not necessarily like it's better in the cooking process or anything like that. They could be adding the oil back, but that's not exactly what they want. So again, it's a design problem, right? I mean, this solution may end up being like a mixed solution, saying, okay, we still want, 5% of that to be coconut fat for the aesthetic reasons. And you can use your nano-emulsions if you want to for the rest, okay? But it's a marketing thing. So, yeah, more than a technical issue. Yeah.
Interesting. Thank you. All right, we have another question from Deepankar, who asks, could you please share your thoughts on moringa oil and the usage of moringa leaf powder in plant-based alternatives, as moringa leaves contain great protein as a plant? Any thoughts?
Any thoughts? No, I do agree. Yes, I mean, just by chance, yesterday I was reading about moringa. Mysteriously, none of our students have looked into moringa. I think that's for next semester. And I think you have a very good point there. If that moringa leaves have a lot of protein, I mean, they're called the miracle berry or something like that. Yeah. But my thoughts are like, we have to look into that. If it makes sense in terms of the supply and where you're looking for that. If the moringa leaves, depending where in the world there's a larger supply of moringa leaves, that it makes sense for that community to look into that.
Awesome. Thanks, Ricardo. From Luca, we have a question. Actually, I just lost it. Oh, here it is. Our team experimented with oil, water, protein emulsion to produce an oleogel, and we were able to get a very stable emulsion that was temperature stable. Would you be able to talk about the benefits of using saponins instead of cheaper soy protein that can still form a stable emulsion even without high shear mixing?
Yeah, I mean, this is something, as I said at the end of the talk, that we were going to start looking into, this mixed surfactant systems. I know teams like the one led by Professor McClements also, they have looked into that. There's literature saying that there are some advantages on using the mixed surfactants, since you get, the mixed properties in terms of strength of the gel around the oil. And so my understanding is that, let's say, lecithin or other surfactants they have a higher requirement to cover the oil and make stable emulsions. So anything you can do in mixed surfactants, I think it's something to go for. That's what we're going to start looking into in more detail.
Wonderful. Thank you. User PC asks, I always thought saponins were very bitter. Is the amount used insufficient to introduce any kind of off taste?
Well, I'll tell you an anecdote, okay? So they have a bitter taste. Now at around even like 300 ppm or so, which I drink daily, the taste can be masked really well with, let's say, a little bit of orange juice, like one. Okay, so I don't think at the amounts where we are planning adding, they will have any taste issues we cannot deal with. I mean, the bitterness, part of the bitterness of a crude extract of saponin is due to the phenolic compounds. Now, this product that I show you there, it has most of the phenolic compounds removed. But still, if you taste, it's a little bit astringent, but not at the amounts we're going to add. I mean, that compound in a beverage, like let's say like a sport drink, you add a few drops and it's not there. It's used at a higher dose as the foaming agent of the root beer in the US, and doesn't have issues. So I think in a complex system like a burger, that's not going to show up.
Awesome. Still 35 open questions. Ricardo, do you feel like you'll be able to stay a little bit past the top of the hour, or?
I'm not going anywhere.
All right, sounds good. We have it in place.
Yeah. Yeah.
All right, wonderful. And a question from Nilu. And I think this may have already been answered in the chat, but I'll ask it here anyways, in case you have any additional comments to add. How do you improve the bleeding in the plant-based burger? Is it true that the leguminous plants do this? And if so, how will they compromise the properties of a plant-based burger?
I'm not an expert in that. I know how impossible does it. I mean, they started the bleeding with the heme isolated from plants, but that was not enough. It wasn't economical to do that. So they took that gene and they isolate and they put it in the yeast, and that's how they produce it today. So they have yeast that produce heme, the red color. So when you go and visit Impossible, they serve you blood, like a blood red stuff, like if you're Dracula or something like that. So I haven't seen, I mean, other people do it with other food colorants. They don't use this heme bleeding stuff, okay? Like Beyond Burger doesn't use the heme of Impossible. They use other food colorants. So I don't know if I answered the question or not, but maybe not. Okay.
No, I think that sufficiently answers the question.
Right.
I think this is an interesting question. Do you think that the limit on saponins per weight of a product is merited? If not, is there a way to challenge it by regulatory means?
I think because it was challenged already in the European Union just allowed more per day, and so that's now, that was a 2019 regulation. So I don't think those regulations don't change like every other day or every other year. So I don't think there's room for asking for them to allow us more. But that was an improvement of the FDA, you know, and they were talking, before it was based on the amount of product, which was very ill-defined. Now they're talking about specifically saponins, like 3 mg of saponin per day per kilo body weight. That's what they're saying. Okay, so I don't think I mean, you can argue that they're very safe, but at the same time, you know, and as we speak, it's being tested at the Center for Emerging Diseases at UC Berkeley, if it could be an oral blocker for the COVID. So it has a lot of other implications, right? So our human body is very complex. So I wouldn't, you know, just put twice as much there. So I'm trying to comply with the regulations here. Yeah.
Thanks. From Asaf, can you please share scientific data about the mechanism of quillia to stabilize foam and fat?
Oh, that probably would be offline because I mean, there's so many papers out there. I think the one I quoted, the 2019 paper from Germany, that's a very good compendium to understand all the properties, how it creates these microfibrils around oil globules, and there's mention to the foam properties. At the more fundamental level, there are quite very strong groups from Poland talking about all the surface properties of these quillia saponins, how they aggregate in the surfaces, how they interact together, one next to the other, to create this strong film around either air in the case of foam or oil in the case of emulsions. So it's not just the saponin just sitting there in the interface, it's the saponin also interacting between themselves to create a strong network. And that's what gives strength to all these constructs. So I think, I mean, if I could follow up, there's a lot of literature on that. Yeah.
Awesome. What's a good email to reach you at if people want to follow up?
Okay, so it would be R San Martin, SANMARTIN at berkeley.edu.
Awesome. And we will send that out in a follow-up email.
Okay. I must say that since I moved the lab to the house and I'm the only technician and, you know, PI and all of that, it's just one-man show now. I'm a little bit slow answering emails unless okay, until the classes are finished. And the class will finish like May 10th or so. So be patient, okay? Because
Sounds good.
Yeah, and especially with the COVID thing, they're asking me for more samples and I'm preparing them in the garage, so.
Awesome.
Okay.
So
Yeah.
ask away, but exercise patience or equanimity. Okay, sounds good. We have another question here. Did you get rid of methicellulose completely in your standard formulation? If not, what do you intend to explore to get rid of it?
Okay, so in the little burgers that we first prepared, the methicellulose is there. Now, we have the recipe from Nutriati, and they claim that they don't have the methicellulose, but they have a very fine powder, probably starch. I don't know exactly what it is, but they got rid of that. I think you can ask the details to Nutriati or just check in their website, but they're not using. Other companies are exploring patatin, but it has some flavor issues, which is the protein from potatoes. That has a very good gelling properties, but has some flavor issues, especially if you put coconut fat there. Okay, I mean, creates very awful flavors. But I think you can get rid of the methicellulose for sure. I mean, like using those compounds that you can check in Nutriati's website, or other compounds like proteins that gel. So I don't think, I mean, that could be done. can be done. So I plan to use Nutreti's recipe. Okay.
Okay.
Yeah.
Looks like Hamas is asking, assuming we can produce animal lipids without animals using cellular agriculture, will there still be a need for nano-emulsions? And they're thinking only on the, I guess, organoleptic properties of the experience, not about the health.
Well, I mean, again, it has to do with how we design our foods. We don't think we have to go to cellular agriculture to provide edible oil. I mean, that's the bottom line. I mean, cellular agriculture is super complex. It has a lot of safety issues. If there are mammalian cells that are grown, they have mammalian viruses. So it's not like growing beer in your backyard. It's mega expensive. It has strong limitations on the amount of cells you can put in there due to viscosity values. So, I mean, if you ask me, do you think cellular agriculture will ever fly? Nope. Okay. So, but to produce fats, which is easy done with plants, I don't think that's the way to go.
Yeah, I think the question is like, let's just assume that cellular agriculture is there and all of these technical limitations don't exist at the moment. Let's just say we've made it. Do you still see there being a role for nano-emulsions in those products?
Well, they're fats anyway. So, I mean, they have to be emulsified anyway. So I mean, meat is a multi-phase thing. I mean, if you think about, let's say, ground beef, animal ground beef, it has their own emulsifiers that are natural present there, but fat has to be emulsified in that system. Okay.
Yeah, thank you.
Yeah.
All right, another question is from SP. Can nano-emulsions have an impact on the melting point? So will the canola or the sunflower oil melt at a higher temperature to give a desirable mouthfeel like coconut or palm?
That's a good question. The melting point is the same of the oil. The oil is just trapped in this structure. So the oil never change phase, right? So now, how would that play with the mouthfeel? That's something we should be sorting out in the next, hopefully 2 months or so, okay? Because we haven't, I mean, we've done very limited taste experiments because until a month ago, we didn't have the Nutreti recipe. So we didn't have any recipe we could test like a tasty burger, you know, tasty plant burger. So now we have that, and so we don't know about really the culinary experience of having the oil trapped as nanoemulsion compared to the oil, you know, floating there like in big chunks, so that's what I said. It may be that it's still for the tasting part, or it will need some, you know, fat floating there, you know, not as a nanoemulsion. So, but that's something we will do in the next months, hopefully, when I get students back. The campus is very close now, you know. But I was able to take the synthesizer and all that equipment. I just went in there and I sneaked in and I just put it in the car. Okay, so I have a very packed garage now to do these experiments.
That's great. A question from Raphael. It says, okay, you've given a really super interesting talk, so thank you. The question is whether the weight loss that you're experiencing or you're reporting after the cooking, is that the total weight loss including water, or is that specific to oil?
That's a good question. We've thought about that. It's in comparable terms, it's in both cases, it reflects also water evaporation. Now we're going to do a more detail, you know, using succulent extraction and just seeing how much oil was retained there. So what we also measure is the leaking of oil. So we measure really what leaked. So we weigh those little pans and see the oil that leaked. So we're reporting that too. So it's not just, but you're absolutely right in terms that there is a water evaporation there that happens. and we even put some oil in the little pan, so it absorbs that oil again. So we measure everything, but we need to run some detailed experiments on oil extraction after this was done.
Got it. Yeah, and this is kind of a semi-related question from Ray. Could you describe how you set up the oil leakage experiments? So what temperatures did you use and how long were they cooked for?
Well, it was in a very, I would say, I'm trained as a scientist, but I'm a little bit a mercenary in these things. Okay, so I put those weighing aluminum pans there, and I had a very detailed microscale, and I prepared the little burgers, and then I cooked them 3 minutes per side on medium flame in my kitchen on that iron cast that shows in the pictures. I don't know if you saw like an iron thing like this size, you know, and I warmed that out. I mean, like all the time at the same time. Then I put my little aluminum there with the burgers, 3 minutes per side. I change them and I weigh everything after that. That's the way this rough preliminary experiments were run.
Okay. Awesome. We still have 28 questions, and people are very eager to
I wasn't
learn.
very clear with anything, you see, because people are asking more and more. So.
No, I think you're very clear. You're just inspiring additional curiosities.
Right. So.
All right. There's another question here about asking you to describe the hydrate, or actually they say you've described the hydrating the protein isolate in the emulsion preparation, then heating the system. How do you introduce the necessary structure required for the appropriate texture? So I think maybe...
I'm not sure. I mean, the structure is given by that protein isolate. It's already structured. I mean, it's like fibers. So when you soak them, and you make the patty, I mean, it looks like a real burger. I mean, like a burger, really. I mean, if you chew that thing, it's like chewable. It's like, it has structure already. The structure is given by the protein isolate. Okay, so yeah. And going back to the oil question, I mean, what we're really interested in that leakage of oil. So, I mean, we know there's water evaporation, but we wait what was lost compared to what's reported it had. Okay, yeah.
All right, thank you. What is the influence of oil droplet size on flavor perception? If flavor is mainly oil soluble, would the very large surface area of the nanoemulsion to which it is exposed during product mixing be a good or a bad thing?
I think there is a relationship between size of the oil droplets and perception of creaminess in other foods, yogurts, and so there's my understanding is smaller size gives you more creamy kind of texture in mouthfeel. Okay, now we don't know, that's where the panels come in, right? How this will be perceived by someone eating this stuff. It may be that it's perceived dry, you know, with a sense of dryness because the oil is so trapped, you know, but yeah, I wouldn't add more to that. I don't think the flavors there, it's more the mouthfeel. I mean, like the flavor of the canola oil or whatever. I mean, I don't think that will make a big difference in the flavor recipe of, let's say, the Nutriati burger or the Awesome burger or all these burgers out there. The flavor is, you could deliver flavors, also oil soluble flavors in this nano-emulsions too, if needed. That you can do. Yeah.
Thank you. From Elin Lee, some of the oleaginous yeasts that I worked on can also secrete extracellular lipids, which is also a form of surfactant. Apologies, that's my dog.
Okay.
The benefits of working from home.
Where are you reading? Because, yeah, that's a long question. Start again, please. Start again.
Yeah, do you see the Q&A section at the bottom, Ricardo?
No, I'm seeing 23 Q&A.
Yes.
No, it's not the chat, it's the Q&A. Sorry. Oh, okay.
Yeah, it's at the very top there, and I'll be right back. I'm gonna grab the door. You can answer that question while I'm away.
Okay. So it says some of the oleaginous yeast that I work on can also secrete lipids, which can also form a surfactant. Is there any form of oil that you will be experimenting in the future apart from saponin? And I mean, the saponin and the lecithin are the surfactants here. So we don't plan using any oils that are not locally available and that readily available. I think that's the bottom line. Like, I don't plan like testing extracellular lipids from that, you know, that produced by fermentation or anything like that. It will be just trying to test local oils. I mean, oils that are readily available to do this. Yeah.
I missed most of your answer, but I'm
No,
sure.
the answer was very short. Okay. So,
I'm sure you answered it.
Yeah, the answer was very short. Okay. You tell me. Yeah.
Okay.
Yeah,
Sounds good.
you read better than I do, so you read. Okay.
I'll try. All right. Jorge asks if there's any considerations that you've made around this through electrostatic binding ruled by Quilea saponin anionic surface charge behavior with cationic regions around or inside the plant-based burger, perhaps.
No, that's
Should have read
an
that
interesting.
one.
Yeah, no, that's a good question. But I mean, we know the charges of the saponins. Now, we don't know exactly what are the charges inside the that matrix done by the extruded protein. So we don't know exactly what's the surface charge behavior of the. We don't want to go into that detailed experiments until we prove that this is it gives you a good experience to the customer. So that's where we are now, testing if it gives us a good experience, then we can go deeper into why it's retaining the oil it's being retained, or why, you know, or why it's not producing the nice taste that it should have. That will be like afterwards. First, we want to see if the burger, you can eat the burger and it seems okay compared to the one with coconut fat. Okay.
Okay, from Subra, have we not made any advancements in the extrusion process that enable us to add oil or fat during extrusion?
Doesn't seem like. We just had, you know, when in our classes we have talks by Buehler or Wenger, which are the main producer of extrusion equipment, and they are their comments are exactly aligned to what I said. The protein, the incoming raw material has to have very little oil, because the shear, if not, the shear doesn't happen. Okay.
Olivia asks, did you experiment with quinoa protein and saponin?
Quinoa protein and saponin? No, I haven't. The saponins of quinoa, which are abundant, especially in the hull, they're triterpene saponins too. It could be they're bitter than the quilaya, because you have to take them out to be able to eat quinoa grains. I have done previous work with quinoa saponin, but for a biopesticide. So I haven't done that. But so I don't know much about the structure of the quinoa protein. And my understanding, it doesn't lend too much to an extrusion, you know, to get the right texture. That's my understanding. Not all proteins lend to being extruded and giving like a fibrous structure.
All right, from Ratuha, thank you for your presentation. It was short and sweet, yet knowledgeable. Can you talk about using the chemical engineering approach for increasing juiciness? Does it have something to do with unstable emulsions?
Juiciness. No, I will pass on that one. But I think maybe afterwards, Professor McClemens can comment on that one of the juiciness. What's exactly the juiciness? But I think maybe juiciness is more related to how that water water is released in your mouth when I would have to go and look into that, but I imagine it's not necessarily the fat content, but also the high water content of the burgers that, you know, that are there. So when you release the juices, when you eat the thing. So I think it's more related to the water. I may be totally wrong. Yeah.
Here's another question from an anonymous attendee. So we can't use quilaya extract alone as a surfactant. Is that correct? Because the allowed amount is only 2 milligrams, but even 4.7 milligrams shows high particle size. So it seems to be unstable. Is there any other vegan emulsifier options to lower interfacial tension?
Yeah, I mean, that's what I was saying. They're not stable. I mean, 400 nanometers that we get at 5 milligrams per oil, that's very small still. That's not playing us against the stability. It's like, I think, as I said before, mixed surfactants with soy lecithin or any other plant-based surfactant should be able to do the trick. What we've seen in the literature is that if you mix these systems, there's a synergy, and then you can lower a little bit more the saponin. Okay, so that's our bet here. Or you can put some alcohol. I mean, there are alcohols that are flavoring agents that are not, you know, I mean, don't imagine like ethanol or something like that, but they're flavoring agents, and let's say this from citrus or I mean, like citric fruits, something like that, and those can lower the surface tension up to a point where there's a paper out there that says, I mean, you can add really minute amounts of saponin to stabilize emulsions when you use alcohols. So we will be looking into that too. Yeah.
It's exciting. Someone asks, sometimes the fat release during cooking helps with the browning of the patty. Would oil retention hamper getting that desired brown color in kind of cooked meat?
I think the color is due to the Maillard reaction more than the oil. You know, that's my understanding. And so companies that make this, it's more like the protein with sugars, and that's where the color, you know, the brown color comes from. I don't think it comes from anything like that the oil is turning color or something like that. I don't think so. So actually those patties, when we use the Nutriati recipe, they look very burger-like. Yeah, yeah. They don't look as pale as the one I show, you know,
Yeah.
because it has color. I mean, it has red from, what's the name? Betterag, like, yeah, I don't know the name in English. Okay, but it's a common color. Yeah, red color, right? And so it looks, they look better than that pale color that I show. That pale color was just protein, water, and the oil and the emulsion. That was it. There were no salt. There was nothing there. I mean, you couldn't eat that thing. Okay. Yeah.
All right. Good to know. Yeah. So adding beet juice or something could add that color
That's
back.
the one. Yeah, the beet juice. Yeah, that's the one that was leaking, you know, in the Beyond Burger, in the pictures and then the videos I showed. Yeah.
All right. There's a question here from Talita around which plant proteins you think would be the most suitable for this type of a burger product. And maybe you can also speak on what underexplored plants you think people should pay more attention to beyond the soy, lentil, pea protein that we've seen used.
I wasn't expecting that question, but I would say it's a design problem. If you want the same structure of the meat or the same texture that a meat burger has, you probably have to stay with these protein isolates to get that structure. Now, what we are trying to do is try to refine those proteins from plants as little as possible and stay with other things there, let's say starch or other things that are present, and create texture, but that not necessarily is going to be the burger, you know, exactly the same mimic of the burger. it will be something different, but it will be savory and it will be tasty anyway. So we think any other plant that has texture to it, the protein, the whole plant, is a good candidate for what we're trying to do. But we're doing, for example, the students are doing savory bars, protein bars with beans, but they're not sweet like normal protein bar, they're savory. So I would say, depending on what kind of food you want to design. In this specific project, we're targeting meat, but that doesn't, like this meat that has to be like meat, exactly like meat, but that's not necessarily the focus, or mostly 90% of the projects we do at Berkeley. We try to do something different. Yeah.
Thank you. Victor asks, what are the most important characteristics of the oil for the emulsion? Is it the fatty acid profile? Is it the triglyceride profile? Or is it that the emulsifier plays a bigger role than the oil?
I will answer like a naive answer. I'm not an expert, like what oils are really best to do the trick. I've been guiding the research on what oils are available, and that people agree they're healthier than coconut fat. That's what I've been doing. Okay, now what I've been seeing is, like, if I emulsify one oil or the other oil or canola or sunflower, I get about the same results in these typical oils. So it means like lowering the surface, the interfacial, like stabilizing the interfacial properties with the saponins are the most important part of it. But that person that asked that may be right, that perhaps of the chemical nature of that oil, there may be some advantages in oil stability or not, but I'm not sure about that one. Honestly, I'm not. Okay.
Thanks, Ricardo. I want to do a quick check-in. How are you feeling? We're 18 minutes over.
No, I'm feeling well. I regret that I'm not, like a super expert in emulsions, right? I'm doing an emulsion project. I started saponins and emulsions about 20 years ago. I gave a talk at the IFT. I remember that. And my first steps on emulsion, I read from the book of David McClemens, which is a fantastic book. That was 25 years ago or so, I don't know, right? So, but I never pursued a career like doing emulsion. I saw an opportunity in this. And I think in the plant-based space, sometimes you don't have to be the expert. You have to know who is the expert. In this case, Professor Radke is the expert, and so he guides me whatever I do. But at the end, you have to sort of integrate a few things. I happen to know of saponins because that's what I've been doing in the last couple of decades, right? But saponins for other purposes, for other and I'm more like a process engineer myself. I develop big process, scaling up. And so but I think integrating knowledge and having experts from different parts, that's the way to move in this field. And no one is an expert. I'm not an expert in the flavor, but if I encounter that at the end, I'm going to talk to Givolan and ask them, how do I fix this, right? Okay. Those are
that's so right. As much as it would be awesome for you to be an expert in literally everything under the sun, I think you've already blown us away with how well you're able to, access knowledge from all of these disparate fields and apply them to your research. And also, something came through in the chat earlier, just commending you for your research being a really great example for why product developers should engage with these downstream aspects, including like regulatory considerations very early on in the R&D process. So I think it's really refreshing that you have this holistic view of the supply chain, and in addition to,
I start with the cost all the time. You know what I'm saying? So if it makes sense or not, then where am I going to get these raw materials from? Are they locally sourced or not? I can do the best research and then at the end, or the best burger. But if that means, packing a ship full of, let's say, nuts that are on the other part of the world, I don't think that's going to solve anything, honestly. I don't think that's the solution for a change of people moving to more healthy or more, sustainable product. It has to be holistic. I don't think if you drive a huge truck to go to McDonald's and eat an Impossible Burger with
Yeah.
change anything or throw away all that packaging. You know, it has to be holistic for
Yeah.
them to have a real impact. So I think, you know, looking at the raw material availability,
Yeah.
how this is going to be distributed, it's going to be frozen. Well, bad news, you know, all of the tropical countries, I mean, they don't know about a fridge or anything like that, you know. You don't get those things. So this is a solution that's going to hit few people only. It has to be holistic. There's no way out of that. Okay. Yeah.
Yeah. Um, this is wonderful. Another question from Oscar. You already touched on this a little bit, but they ask, in plant burger applications, mimicking the visual experience of small bits of animal fat in the patties could also be important. So you talked about the aesthetic importance of coconut fat. How would you address this? And I remember you saying, you know, maybe it's 5% coconut fat for that aesthetic appearance,
Right.
and the rest is, yeah.
I don't know. You know, it may be, you know, the gels produced with the same saponin. When I said you can spray dry this, you know, you can dry the thing and it's like a powder. Inside each of these little powders, there's oil in a liquid form, but it feels like a powder. So in the lab, we've been drying stuff and it looks like, feels like, you know, like gels, like a jello, okay? So I don't know about how I'm gonna color that, but it may be that I can still get away of putting some big chunks of, you know, structure oil, because that's what it is, it's structure oil, and having that whiteness or streak, you know, it would look like streak, but I haven't explored that. And if not, you will have to put some visual, you know, little sprinkle some on the top there, if that's what people want. But I don't know. If you open one of these patties, I don't know if that's what people want, honestly. You know what I'm saying? It's like you open them and if they melt, you don't process them immediately. They look like clay, honestly. They don't look like white. I mean, they don't hold like regular meat, ground meat. They just go apart. So I haven't thought about that yet. Yeah.
Yeah, that's interesting.
You have to think something. These are research topics that I put towards my students, and they should be answering most of these questions, okay? because as I said before, we're not a research program in the sense that we're not the department of, you know, whatever, of chemical engineer. We're not that, right? That, you know, very rigorous research like what's done in Berkeley. This ended up in the research field because of the funding we got, because of this grant of the GFI. We realized we had to have a small lab to start doing research, but not at the level of other research teams, let's say Wageningen or all this, you know, in the world. We're not at that level. And I don't think we aspire to being at that level too. Okay. Yeah. It's more
Yeah.
like applied product development kind of stuff.
Yeah, and rapid iterative experimentation. I
Yeah.
mean,
And
so
it's for the students, you know, I mean, but we have very nice rheometers and we have texture analyzer. I mean, we're well equipped, but it's more for the students. And I was about to hire someone that really knows the stuff, but then the COVID situation came in. Okay. Yeah.
yeah, I think it already yields, I
Mm.
mean, just with this experimental model, so many important insights for the field.
Yeah.
I think, look, we have just 5 minutes left to go, so we
And I
won't.
want to answer one from Daniel.
Okay, yes, please. Take a
Daniel
look at
says,
the list and
you,
answer
you
what.
mentioned that the Equilaya saponins are used in vaccines and adjuvant. Also, you said that the heat and pH stable. That sound they can handle in the stomach? Yes. What are the chances of oral ingestion of Equilaya saponin giving an immune boost? High. Drink root beer, basically. And that's what's being tested today as we speak at the Center for Infectious Diseases at UC Berkeley. We're not testing it as a vaccine adjuvant. We're testing it as it may block one of the proteins where the virus attaches in the intestine, not in the oral, I mean, not in here, but it does boost your adaptive immune system. And that we have patents that we have protected animals from viruses because of that. So that's what we ask the Center for Infectious Disease to test.
All of our fingers crossed. Okay. It does seem like we have room for 2 or 3 more questions before.
Yeah, I will probably have to jump like at 11:30. I mean,
Yeah.
11:30 my time, like in 4 more minutes. There's a question here. What equipment? Well, I use a sonic. I mean, like I can send you that details. Okay. Of the sonicator I'm using, and I'm looking into questions to see if there's some about color, which I cannot, how it is labeled. I think it's Culaya extract. That's how it's labeled. Okay, that's what the regulation says. Yeah. Oh no, choose one. One more. Yeah.
Okay, I will I will choose one more lucky question asker.
I'm looking for one that I haven't, you know, sort of.
Yeah, touched on already.
Yeah. One are beyond my comprehension, like soy, hemoglobin. I mean, that's not what I know most of.
How do you feel about clarifying again the mechanism that reduces the oil leaking? The questioner is
Yeah,
wondering,
but
you know.
the thing is, what this is the theory, okay? I mean, this is what we expect. If we add the the droplets as, you know, very small droplets, and you have inside the protein matrix, this dry protein matrix, the isolate, you have inside many little channels and, you know, places where the oil can, because of the size of they can penetrate and really go through capillary forces inside the whole structure. So what we are postulating, there must be, like someone said before, there must be some affinity between, let's say, maybe hydrophobic interaction between both sides of the story. Maybe not so much because the hydrophobic part of the saponin is linked to the oil, or maybe the hydrophilic is linking to some part of the protein structure. We don't know that, but we know that if it's intimately dispersed in that microstructure of the protein matrix, in which is a scale of microns, those channels there, that's what we've seen in the literature, then we think it being retained just by capillary forces, something like that. It's not being retained almost mechanically being in there. Okay.
All right.
Time.
That brings us to the end of this webinar. Thank you everyone for asking such insightful questions. And thank you so much, Ricardo, for staying on for so long. We are very grateful to learn from you.
No, I'm sorry I couldn't answer all the questions. I think there's so much room, you know, for people that are experts in this field to contribute to this field. I thank everyone. I thank the Good Food Institute for this. I thank you, Amy. Yeah, that's great putting this together. I think in times of like the times we're living, a good and strong community helps a lot. I mean, this is an exercise on emotional resilience, fortitude. So I think, you know, meeting people that are interesting and moving forward in these times, I think it's very invigorating. So thank you for that opportunity to reach more people.
Absolutely. Thank you so much, Ricardo. Thank you everyone for joining us today. After this call, I will send over the recording along with Ricardo's email, although he's asked that you all be patient because it may take a while for him to get
save
back
the world. I have to save the world.
Yes, that's right. He's working on saving the world.
No, the thing is, there are trees around my here in near where I am. They're native from Chile, but so I sneak in the mornings and take the leaves out. and extract the saponins.
All right. Thank you so much, everyone, for joining us today. We'll be in touch again after this, and we hope to see you again next month for a discussion about using oat fermentation to reduce anti-nutrients in plant-based meat as well. All right. Thank you so much, everyone.